Welcome, Morales community. I'm Phil, head of research at Morales, and I am excited to welcome you to another exclusive dev tutorial. We have with us here Idris of Axelar, and he's going to show us how to build a Farcaster frame for bridging ERC-20 tokens. Now, if you don't know anything about Farcaster yet, don't worry. We're going to recap that here during the stream. And before we get started, let's welcome Idris up on stage. How are you doing today, sir? Welcome here again. Glad to have you for another tutorial.
Yes, GM guys, thank you for having me, Phil. Really excited to be here again. So let's do this. Let's do this.
All right, let's get started. Absolutely. Let me know when you're ready with your screen. And I know you have some slides to share so that we can
Yeah.
get started with this. So Idris was telling me a little bit about Farcaster before the stream here, and he's going to get into a more extensive tutorial of it here very shortly. But basically, it allows you to embed functions of your dApp directly into something like a Twitter or an X post, for example. And I'm sure he's going to give more examples as well. But very soon, we're going to see the power of that at work. And here we are with our presentation. The floor is yours, Idris. Go ahead.
Yes, thank you very much once again. Thank you all for joining. So in this session, we'll be talking about building Farcaster Frame for bridging ERC-20 tokens with Interchain token service. So don't worry, just like Phil mentioned.
Idris, I just sorry to interrupt you, but I think you just muted your mic on your end. I tried to unmute you, but I wasn't able to. I'm going to pull his screen down here for just a second. If you click your mute button within our dashboard, I think that will correct it. Because I see that it's muted right within our studio interface there. Oh, that was it right there.
All right. Am
Perfect,
I
perfect.
audible
Sorry for the
now?
delay, guys.
Yeah, sorry about that, guys. All right, so
No
let's
worries, no
let's go
worries.
back to our presentation.
Yeah, let's start from the beginning again, just for anybody who's joining now.
All right, let's go. Can you bring up my screen right now?
Yep, all set.
All right. Thank you very much. Please let me know whenever I don't know how that happened, but then thank you all for joining once again. Welcome to this workshop that will be explaining and going through how to build a Farcaster frame for bridging ERC-20 token with Interchain token service. So if you are hearing Farcaster for the first time, don't worry. I'm going to go through like how the entire thing started, how Farcaster Frame became a thing, and also what exactly is the protocol powering frames behind the scene. And also take a look at how you can bridge, of course, ERC-20 token with the powerful Axelar's interchain token service, all within a frame. So moving on, my name is Idris Olubisi. I am a software engineer and a technical writer. I currently work as a developer advocate at Interos Lab, working on Axelar. And then you can find me on all social media platforms at Olanesoft. Looking forward to connect with you all. So in this workshop, we'll be covering like the Open Graph protocol. We'll talk about Open Graph protocol. We'll talk about Farcaster frames itself. I'm going to show you all some starter kits that are available to you if you want to build your own frame. Kits that you can quickly get started in less than 5 minutes to build a frame. And also we'll talk about the Axelar GMP and specifically, we'll also talk about the Interchain token service, and then we'll go through the demo, right? So now let me take a step back to tell you a short story about the idea behind this, Farcaster frame, and also why we need this social interaction embedded into our day-to-day application, like our social media apps. So in the recent year, we've seen like very like increased use in social media by individual professionals, groups, companies, and all of that. And then we have seen that this particular increased use, of course, like some rapid evolution within all of these platforms that we know today. But then this trends emphasizes on how social media is increasingly being used to influence, connect, and also transform the global communication and interaction. Right. So imagine you having a social media post that is not just a post where you have like a static piece of content, but a dynamic and interactive content that can enhance the experience while you are on that particular social media application. So this is a simple vision for Frames, right? Which is a way for you to embed mini application directly into a post and then turning them into things like quiz, pools, feeds, or like e-commerce, like you can embed collection and then get people to buy. And also you can have like an application that allows users to mint NFTs, do like bridging tokens like the one we'll be going through during this session. All of these things can be done directly and embedded into this mini application on your post. Interestingly, this inspiration came from a very old technology, which we might be aware of, the Open Graph protocol. And it was repurposed to fit in this decentralized world that we currently have now. So just to reiterate, the journey of Frames began with just a simple idea to make social media interaction more engaging and interactive. And also, developers were given like a powerful tool. This is a way for empowering developers to build mini application without any need for central authority. You just need to go ahead and build the application, and those applications can be embedded into Frames, and anybody anywhere in the world can interact with those frames. So today, Farcaster Frames represent that main deal of decentralized social media that we can achieve. Moving on, I mentioned Open Graph Protocol when I was referring to the old technology that was repurposed to fit in this decentralized ecosystem. So let me talk about the Open Graph Protocol a bit. Open Graph Protocol was originally introduced by Facebook in 2010, which allows web pages to become a rich object in social graph by defining structured metadata. So the Open Graph protocol itself is widely used for social media sharing, enhancing SEO. If you have worked with SEO before, you have used Open Graph protocol. Either you know or you don't know. So, and also improving links for preview across different platforms. And it remains very simple, but a powerful tool for developers to control their content, how it is represented, and then where they are sharing it online. So let me show you what the Open Graph protocol looks like. So I know this might be familiar to you, or if you're seeing it for the first time. A lot of people that are familiar with like SEO, customizing their application for SEO, which is search engine optimization, they might have used this or seen this before in their application, where you could set things like meta tags for your application. You can pass in the OG title. You can reference the title here. You can pass in another type, and in this case, it's video.movie. You can pass in a meta property like URL. You can pass in image. So image here is just a static file. So if you ever try to maybe use any of these application or like any URL that you've seen online, and you try to copy, or let's say you use a blogging platform where you publish your content, and then you copy that URL and paste it in, let's say X, for example. You'll see that there will be a preview that is being loaded. Those are like meta tags that is already customized for that particular content. So you see things like title, you see the image of that particular content, and you see the URL, right? This is exactly what is previewing that thing. And this is what Open Graph does. So now let's talk about frames. Now you understand what Open Graphs are, but what exactly does Farcaster Frame looks like, and also how does Farcaster Frame extend what Open Graph is currently doing to even allow you to do something that is custom other than just having like a URL and a static image. To keep things simple, frames are just standards that for creating interactive and authenticated experience on Farcaster, right? And this is embeddable in any Farcaster client. So we have a lot of Farcaster clients today. But the top ones that I've used in the past that I've seen is Webcasts. Webcast being the most popular, clients. We also have Supercast. We have Yop. we have Canvas, we have Launchcaster, and a few other ones. Frame became like a significant feature because it typically just extends what the Open Graph protocol can do today. And then it is helping the system to address critical issues in social media by leveraging innovative technology in this case, allowing developers to build and also aligning with the values of decentralized community. Combining all of this together and giving you an e-commerce or a commercial experience while you're scrolling on your timeline. So how does the Farcaster Frame tags look like? This is an example. If you take a look at this example right now, you see it's kind of similar to what I shared for Open Graph Protocol. But one thing you should note here that we now have a different identifier. When you are using Open Graph Protocol, you have things like OG, but in this case, you are seeing FC, right, which means Farcaster, right? FC for short. And then you can specify things like frame, you can specify things like image, and also reference like the link to that particular image. Another cool part is that you can also still utilize the OG meta tags into your frames directly. So because it's extending, it does not mean that you cannot use it within, but it just means that this particular content will be a static content compared to you calling a Farcaster frames like this, where you can now specify, you can see this last option, specify that you can embed things like buttons. And then in that button, the button could have a particular action, maybe to upload something, to mint an NFT, to do this, like depending on what the use case looks like. Now, let's quickly take a look at what like the Farcaster frame flow looks like. You have this frame for a quiz, and then it shows welcome to the quiz, and then it has a button here called get started, and you click on that button. It takes you to another screen within the same application without taking you out of any of the Farcaster clients you might be using. And then you see another screen saying that who is the greatest caster of them all. You see option 1, full, option 2, bar, right? If you select bar, it shows you another screen saying congrats, collect your prize. And then you can also still embed external links if you want to, right? Depending on the use case. But if you pick full here, it means that wasn't right. It's going to show you another screen saying this was not right, and then allow you to also click a button that takes you back to the main screen to start the game all over again, right? So that's the idea, like having a frame other than having a static image, but then you have this image that is interactive, that contains things like button, external links that you can interact with in the long run. So I'll pause here a bit to check if we have any question, and also if my mic is still working. Phil.
Coming through loud and clear, all is well there. And so I think I understand where we're going with this at this point. So more than just a simple quiz function, today we're going to be embedding ERC token bridge transfers using the ITS protocol via frame or Farcaster frame. Is that correct?
Exactly, that's correct.
All right. Well,
yeah,
please
so,
continue. This is exciting.
Yeah. So in case like this is your first time hearing Interchain token service, I will run through it quickly. But we have a video you can check out on the Moralis YouTube channel where we go in depth on what ITS is all about and how you can also get started with ITS. So now we are combining Farcaster and also ITS to build an amazing frame. So moving on, you might be wondering, now that we've gotten an understanding of what frames open graphs are and also what Farcaster frames are, but how does it even look like in real world? Like, does this frame already exist? Are developers already building frames? What are some of the things that you need to know to build those things? Or like, what are some of the examples that you can see right away? So one of them is this, right? You can see this particular frame that was built by Nadaya was built for the purpose of talking about this particular hackathon. And then a user can directly click on read more to read more about the hackathon. It takes them to another frame, or they just click on official rules. It takes them to external sites. directly from the feed, from their feed, they can interact with this particular frame and then being able to like sign up and do things like that. Another example here is the one from JC, where he was talking about on-chain summer, and then now you can see you can meet your NFT directly here. Either you want to meet it directly within a frame, or you click on meet, it takes you to a URL that eventually meets that that NFT and then redirects it back to your client. Or you want to nominate a friend, you want to view collections. These are examples of things that you can embed. Additionally, you want to build apps on Ethereum. You have this particular project, Speedrun Ethereum, that is also talking about Ethereum and also things that you want to do with Ethereum quickly. And then you can see a start button here that takes you to another Farcaster Frame screen, another screen entirely, and also your GitHub, like a GitHub link here that takes you to external URL. So that's the whole point, right? And also this one that was built a while ago, building a Farcaster Frame to send a multi-chain GMP messages, right? Where you can just interact directly and be able to send message from one protocol to the other. So now, how does Farcaster Frame works? We've talked about the architecture, we've talked about what it's extending, and we've shown some, reward example. But there's a particular architecture I want you guys to see so that you can picture what it looks like from the client to the frame server and then to any Farcaster hub that you're interacting with. So this is an example right now, right? We have the Farcaster app, the client that I mentioned. Webcast is used as an example here. So it could be Supercast, it could be Yelp or Canvas or any of these clients. And then a frame would always have an action, right? Maybe you click a button to bring another screen, or you click a button to take you to another website. All of those things are called actions. And then you interact with a particular frame server that was set up. And that frame server could also interact with external protocol like maybe Ethereum, Optimism, Base, in fact, Moralis APIs, all of these things could be embedded.
Idris, you are actually muted again in the studio interface. I'll go ahead and pull your screen down.
This is strange.
Yeah, it is very strange. I wonder, I've never seen it before either. So
yeah,
bear with us here, folks. We'll make sure that we get through it all. But as you were, please.
Yeah, so thank you very much for that. And also, sorry for breaking transmission, guys. But then the concept is, this is how different architecture looks like. You can, like I was saying, you can have a Moralis API calling a particular data on chain here in the Farcaster hub, and then you go to the Farcaster frame, so the frame server to interact with that API, and then it brings back results to your Webcast, your clients. That's the frame client. It could be Webcast, it could be Supercast, or any of these other clients. So this is how you should picture it. We have the frame definition, which is the app widget that is going to render whatever actions that you are sending, and then we have the frame server that handles all these action, that consults the hub or like the external APIs that you're interacting with, and then return the results back to the clients. So now, what are some tools and frames available to you? So the thing is that you can go ahead and start building, with meta tags and having meta tags everywhere, but it becomes, just imagine you want to build something like really robust that has like different screens, different functionality based on user interaction. It becomes a little bit messy if you are just putting meta tags here and there and then trying to customize. It does not make you, it's like you won't save a lot of time. Instead of focusing on like your business logic or like the custom function that you want to have, you end up wasting a lot of time with figuring out why this meta tag is not returning what it's supposed to return. So, but then we already have like starter kits and tools that it's available right now, and it's free. You can just check it out. It allows you to build frames by just calling this function, and then under the hood, they will set in the right meta tags depending on the type of function you call. The first one here is a frame in 100 lines. This is a very simple repository that if you want to get started with Frame right now, you can just clone it, deploy it, and then test it on Webcast immediately. Right. I love to always reference this repository because it contains like basic things that you want to do: sending transaction, hosting, linking to any external website, and all of that. So these are things that you can do at this point. Like you can quickly get started to learn about, which is like a basic for you to start building your own frame. So you can check it out, a frame in 100 lines. And then we have frames.js. This is a package on its own that you can install that allows you, gives you the ability to create multi-page frame. When you install the package, you just have like functions to call. You can do things like performance check. You can do query panels. In fact, you can do state management. They help you do all of those things. And then under the hood, what they're just returning is they're returning all your meta tags that is required for a particular frame um, to actually happen on the Webcast client or like any of the clients that you're using. So this is another one. Another one, which I also want to share with you guys, is frog.fm. They are also kind of similar to what frame.js does, but then, different tools, different performance, and also like different reasons to use some of this package. So depending on your choice, you can just check them out and you just installing them. You have option to like some of these functions that you can just call directly, and then you pass it the required parameter and they really return the appropriate frame for you. And just for you to know, they are just like components, they're just packages, front-end component that you can check out. And then finally, we have the on-chain kits, which is also a React component, but then they have components specific for frames for you to use frame. I used on-chain kits in this demo that I'll be showing with you guys in a moment. So they also have this, and the reason why I'm using it is like it's also pretty straightforward to utilize. If you're already familiar with building with React or front end, you can quickly set up, install the package, and then call the function to send a transaction or to redirect to a particular frame, depending on the action. And then finally, we have frame validators. So you don't want to build application, you don't want to build your frame or any backend and connect it to a frame, and then you can't even test. Like, how do you test before you share with the world about that particular frame? Like before you tell your friends to use that frame, how do you even test on your own to validate that this frame is working as expected before you let the public know about it? That's why we have the Webcast Frame Validator. Webcast Frame Validator is just a very simple tool by the Webcast team, and then just Google Webcast Frame Validator. You'll be redirected to this URL where you can see this is an example of a frame that you can test. Just passing the URL at the top here, you see the frame. You can see this particular frame has like different, button. You also see another cool thing is that you see all of these things showing green mark. So should in case you mess things up and then probably it's not going to work, when the frame loads, you see like a red sign showing you that yes, this thing is not properly configured. So you can test your frame here before you go live. In the demo, we'll also be testing it here before we eventually share the frame that I'll be building live to everyone, right? So this is what we have. But then, is that all? Of course not. Don't worry, you don't have to scream yet. It's not all, because now we've learned about frame, right? We've learned about we talk about Open Graph, we talk about frames, talked about the starter kits that you can use. We also talk about the architecture behind frame. But then, how do we use frames to build a system? Like, how do we use Farcaster Frame itself to build a system that is capable of bridging ERC-20 token from any protocol anywhere in the world, right? This is where we have Interchain Token Service, ITS, right? We'll be utilizing ITS here to bridge our ERC-20 token from one chain to the other. In the example, we'll be bridging from Base to Optimism, right? But you are free to use any of the supported chain by Axelar today to do this bridging of any of your assets that you have on chain from one chain to another. So what exactly is Interchain Token Service? Let me quickly talk about it briefly before we go into the demo session. Yeah, Phil, you want to say something?
Well, I was just going to say, we are going to go over a quick explanation of ITS here, but if you're looking for a longer explanation, I encourage you to check out the previous video that Idris and I did, where he explains this in depth. So this will be more of a quick recap, but there is a longer tutorial available for anybody who wants that. Back to you, Idris.
Yeah, thank you very much. Yeah, so guys, feel free to check it out. If you have any questions, let us know. So now, what exactly is ITS? Interchain Token Service is just a suite of tools and smart contracts particularly designed to empower developers to issue, manage tokens, and retain their fungibility across multiple chains, right? And also, of course, their utility, which is important to know that you can interact with this contract to do any of the things that you want to do. Either you want to create a brand new interchain token that can work on any chain, or you want to bridge an existing token, want to create like a wrapper or a canonical version of a token on one chain to the other, or you have a custom token that you already have and then built a custom implementation for, and then you want to extend it, you want to make it, you want to make that particular token that you already deploy on multiple chains an interchain token. You can do all of that with ITS, right? So, but there are a few things that you should note here. That number one, ITS is trustless. Like the interchain token run on open source, code via smart contract on a public blockchain that is secured itself by a dynamic validator set, right? And then number two here, it is fungible, which means that you can easily scale up to, today, you can scale up to over 16 plus blockchain with canonical version of your token that shares the same EVM address across all of these chains. Number three is that it's a no-code tool, like you have a no-code experience. We also have like a portal. If you don't have a coding experience and you want to leverage Interchain token service, you just need to go to the portal interchain.axelar.dev, and then you will be able to enter a few details about your token and take your token from one chain to the other. And then finally, it is functional. Functional here is that you have, they are customizable. Interchain tokens generally are customizable in such a way that you can have any features that you want on that particular token. And then, things like permissions, yield, and all of that. And then going cross-chain with those customization leveraging the interchain token service. All of this is quite simple and pretty straightforward to implement, right? So now let's quickly go to the decision tree. Like, what are some of the options available for interchain token service? I mentioned custom token, I mentioned canonical, and I also mentioned like brand new token. But then let's quickly go over this. First, we have two categories. Like, first is to create a multi-chain token, like a brand new token, or upgrade an existing ERC token that you already have. So let's talk about creating a new multi-chain token, right? So the first question you want to ask is, does your token need customization feature? Like, do you need custom feature? If you need custom feature, then it's very simple. Just go and build a custom ERC-20 token and make it a multi-chain token by deploying the token manager and then linking it up as an interchain token. Feel free to check our docs.axelar.dev to find all the other information that you need to do this custom functionality. But another question is, if your answer to that, the first question, if your answer to it is no, if it is yes, then you need to build it. But if it is no, then you can just head over to our portal, Interchain token portal, interchain.axelar.dev on mainnet. On testnet is testnet.interchaintoken.axelar.dev to create a brand new token and then deploy and share the token anywhere. In fact, directly from the portal, you can add liquidity directly on the portal. And also you can also get like Squid integration. If you're already familiar with Squid, you can get Squid integration. If you want to also do this programmatically, it is available, because we know that developers always like to customize their experience. They always like to do stuff. So it's also available for you to customize. And the other part is upgrading an existing token, an existing ERC-20 token. First, the question here is, do you have your token deployed natively on multi-chains already? If your answer is yes, then all you just need to do is to link this token together as an interchain token using the token manager that we have. But if your answer is no, then you need to do the canonical option. Maybe the reason why your answer is no is probably you only just have your token on Base or your token on Ethereum, and then you want to deploy a simple wrapper, a canonical version of that token onto another chain. So this is the option for you. right? You can either do it programmatically or you also use the Interchain token portal. In the demos session of this workshop, we'll be we'll deploy a token on base and then we'll register it canonically on Optimism. So we'll be using this option during this demo. But then now we need to head over to the demo and see and show you what it looks like to build a frame, what it looks like to interact with the backend, and also what it looks like to deploy your frame, and then also build a function that calls the Interchain token service. So let's head over to them. But before then,
Real quick before we get into that, one thing I wanted to
yeah,
add, Idris, because this is something I tell our Morales Money Pro community
yeah,
when they ask about minting tokens. It is my
exactly.
opinion as a professional in this industry that the ITS protocol is actually the best way to mint a token on chain if you've never done it before. Granted, those cross-chain functions are also there and going to make it even more powerful and easy to manage. And there's other advancements for that reason. But even if you're just starting from scratch and your first question is, how do I mint a token? ITS protocol from Axelar is the answer. Look no further. Back to you, Idris. I just wanted to point that out for people.
Yeah, thank you. Like, look no further, just utilize Interchain token service and you'll be good to go. Yeah, so but before I switch over to like the coding part, I just want to quickly tell you what we'll be doing. We'll be doing three things here, right? The token that we want to bridge, we are going to register it as a canonical Interchain token on base, right? And then we'll be calling this function on the ITS contract to do that. And then this function will pass in the token address that we want to bridge. And then like token address we want to register as a canonical Interchain token. And then this returns like a token ID that we'll be using later on to deploy, to do Interchain token transfer at the end of the day. And then second option is after registering it on base, we also want to deploy it remotely on any chain. In this example, I'm using Optimism, right? And then we are calling this function deploy remote canonical Interchain token, where we specify the original chain, we specify the original.
Your mute cut in again. I wonder if it's a key shortcut issue. Alt D will mute and unmute your mic if that helps. But if not, you can, of course, do it from the studio page as well. Apologize, folks. This is the first time we've had this issue. I don't, could be a StreamYard issue that we're experiencing here. Special shout
Yes,
out to
it's
Theo from
so
our
strange.
Morales Money Pro community. I see him in the chat.
Yeah. Yes. Like I was saying, you just need to call the deploy remote canonical Interchain token on ITS, and then you'll be able to send all of this information and it returns the token ID. This is a unique token ID particular for your token. So this is the second step. And then the third step is to approve Interchain token service address to be able to spend the amount that you want to transfer, because we'll be transferring the assets from base to Optimism, right? And then this is a function to do that. Just call the Interchain token transfer, that's Interchain transfer on the Interchain token service. And then you specify the token ID, you specify the destination chain, destination address, the amount, the metadata if you have any, and then you pass in the gas value that is required for this to work. So let's get right into it. So I've prepared the end result of the entire demo. I already have it on the GitHub, so you can screenshot this page, like access this particular URL, or like this QR code, and then scan it. It will redirect you to the full-fledged project. So, but then the point is, we're going to clone that project, install the packages, build the frame page, build the backend, and then do the 3 steps that we want to do to actually bridge the tokens from one chain to the other. Right. So I'll pause here a bit just for you guys to scan this QR code before I head over to my Visual Studio Code to see what the codes looks like and also go through some of these things in details. Yes, so I'm waiting for 1, 2, 3, 4, yeah, 5. So we'll also share the link of this project in the description. So don't worry, you if you don't have access to it right now, you see the entire project there. You can clone it, you can ask me any question. If you are right now watching this, you can also, ask me any question, and at any point in time, I'll be happy to help. So now let's go over to our Visual Studio Code. But before then, remember, let me go back to this. Remember, the first thing we want to do is to register ERC-20 token as a canonical interchain token on Base, right? Which means that we are supposed to deploy a simple ERC-20 token before now. Like we need to have, that's the starting point. So what I'm going to do is I'm going to head over to Remix, right? And then if you don't want to go to Remix, like for you to get, you're already familiar with OpenZeppelin, you can just check out OpenZeppelin. That's where I got the code from. So it's very simple. It's a very simple ERC-20 token. So yeah, OpenZeppelin. If you go to, if you're already familiar with this, then you can just pick this up. This is where I picked it up, right? Just a very simple token here, and then you can click on copy or open in Remix, any of these choice. So I've done that already, and I have this. But I would like to rename this token to something else. So what do you think we should rename it to, Phil?
Oh, let's rename it to uh Farcast ITS.
Okay. Yes. So and then we can have the symbol as FITS, right? So now we
Perfect.
have this. We have this Farcast ITS, and then this, right? So this is a
It
very
fits.
simple ERC token. Yeah, fits. Yeah, so this is a very simple ERC-20 token. Don't worry, it could be anything. You can write anything there. In as much it's ERC-20 token, it's all good to go. So this is a very simple one. We are also initially minting like 10,000 here. And then we also have a mint function that can, do some sort of minting at the end of the day where you get to mint your token, right? So um moving on, we can now head over to compile this particular contract, which shows green here. It's already compiled. And then we can go here and select my wallet, select this. But then because this, we have like initial owner, we need to specify the address. I'm just going to go over to my wallet and then copy my address and then paste it in here. Oh, sorry, not here, here. That's the initial owner. And then I'm going to click on transact. Right, this should open up like a wallet, any wallet you're connected to. And I'm going to confirm this so that we can deploy our token. So you can see this is now deployed. I think I have one. Oh, now I'm confused. I don't know which one I just deployed. Let me redeploy this and just be sure we have everything compiled. Let me compile once again. Yeah, and then go back here, paste in my address, and then click on transact, and then confirm this transaction is going to redirect back to Remix. This is pending, yeah, and then we have this information, right? This is our token. Our token was deployed successfully. All right, so now we have this token. I can just go back here. I want to confirm something real quick. Contracts, yeah. Oh, okay. Oh, yeah. I was wondering why it's showing my token, but then I realized that that's the name of the contract. So it's fine. We still have our token details intact. So now we have deployed our token. We can confirm that deployment on chain if you want to. But then we have our token here. We can see that we have everything set. We can check the decimal 18. We can check the total supply. You should see like 10,000. I think, yeah, we minted 10,000. And then you can do like every other functions available to you. Now that we have our token, this can be anything, anywhere. Let's go to our frame client. This is what our frame client looks like. But then before then, let's go to our Visual Studio Code to see what that project looks like. So I'm going to close this right now, close all. And then if you clone that particular project, this is what you should have. You should have a very simple Nest.js project. That's with the app router already configured. We have this sign. And then the first page you want to check out is what we have in the API section. We have so many like different routes. But then if you go to page.txx, let me zoom in a little bit so you can see my screen clearly. If you go to page.txx, right, we have this simple information about the project, right, which is to migrate tokens with Interchain token track service on Farcaster Frame. And then we have all of these metadata sets here. And this, with this, we should see a landing page that is showing us something, right? But then there's something I want to call out here. If you can see here, we are using this get frame metadata from the package that we installed. That's the on-chain kit I talked about earlier on. And that is what we are using to render our welcome page frame, right? And then we still have the React application like that, return a very simple UI on the front end that we can take a look at. So because I've deployed this, so let me just go to this URL, show you what I'm talking about. So I'm going to exit this page. So you can see we have a very simple React application showing migrate token with Interchain token service on Farcaster Frame. But this is one frame. This is like the application itself. So if you now want to test like what the frame is returning, that is when you now come to the frame validator and then click on this button. It's going to load up your frame with what the frame is returning. So you can see it shows get started here. And then we have this fine image saying bridge ERC-20 token with items. So I can go back to my application and you see where I'm actually returning that particular button here. So this is why I'm returning. You can see get started. You can see I'm passing the information, the image here and the post URL. Post URL means that, so for every frame, you have action, you have image, you have post URL, we have target, and so on and so forth, right? These are details for the system to understand what exactly you want to do on that particular frame. So with this now, we just said, oh, once you land on this page, show this button showing get started, and then return this image, show this image, and then finally, when they click on that button, take them to the home route. That's basically what we are doing here. But before I proceed, I mentioned during the presentation that if you are using these packages, like on-chain kit, for example, you just call a function, and then under the hood is going to call a metadata. So let's take a look at what the system is calling under the hood. You can see this is the get frame metadata, and then it takes like different parameters like the accept, takes the button, inputs, post URL, refresh period, states. State is very, very important because there are some things that you need to do dynamically, and then you want to like get those value and then reuse them later on, maybe at the end of the frame before the user signs out or something like that. You can use states to manage that particular data and then save it across different frames. And then if you see what this frame metadata tag is returning here, if I scroll down here, you can see there are things that you are already seeing during the presentation here, which are meta tags that gets returned automatically. So when you call that, you can see it's returning metadata like frame button, metadata, depending on what you enter. So if you input like to have a button, under the hood is just helping you to create that metadata with that particular action. And then we also have like every other details like that. So this is how these packages work. And that is a way for you to streamline the process or like reduce the time of you writing meta tags everywhere. So just calling this function, specifying what you need there, under the hood, the system is going to return the appropriate meta tags, right? So this is what the home page looks like. Let me go to the application and show you the end-to-end and then trigger a particular application. Then we come back to our code while that is trying to finalize, if that's okay. So let's go over to the application now. So you've seen, I just showed this page, like there are a lot of components and moving parts, but then let's run through the application end-to-end to see what it should look like at the end of the day. So when I click on get started, I see another frame page, right? That says I should enter my token address. So now you can enter the token address that you just deployed. I enter this, oh, sorry, that's the wrong one. Let me go to the remix again and then copy and then go back to the frame validator, paste in my token address here. Typically, if you want to bridge any token, you need to know at least the token address of that token. So this should be our starting point. And then we'll submit. So once we submit, the system will ask us that this is a token that you've already deployed. But then tell us, like, we know where it's currently living on, like where the token is deployed on, but tell us where you want to register the token on as a canonical interchain token. So in this case, I'll select base, right? These are the three options that you have, but you can customize the way you want. And then I click on register. So what I'm registering here, I'm registering this particular token as a canonical interchain token so that I can be able to bridge that token from one chain to the other. And then I can just click on continue in wallets.
And really quick, just as a point of clarity for anybody watching, when we register it as an interchain token like this, it allows it to automatically manage the supply between chains. This is hugely important for development teams who are needing to maintain a constant token supply across all chains in order to keep their community abreast of what's going on. We've seen situations historically where a community, or I should say a development team, will mint the same token on a new chain in order to go multi-chain, and then the community will be alarmed because of the supposed increase in supply. ITS takes care of that for you, and it's one of my favorite features. So I just wanted to share that with everybody here.
Yeah, thanks for calling out. For calling that out. Thanks once again. So now we want to confirm this transaction, and then we can just click confirm. It takes us back to the frame, and then you can see that on the frame you can see this transaction status that is sent successfully, and then we can click continue. So continue now. We can track our transaction. We have a button that leads us to the transaction to actually understand if this happens on chain or not. So you can see here we have like the transaction is successful 12 seconds ago. If you scroll down here, you see other details and also the function that was called to register this particular token as a canonical interchain token, and then the token ID that was returned, right? So let's go back to our frame. We can now move to the next step. We've done
It looks like you're muted once again here. So sorry for the issues, but you may need to unmute that from the studio page. I'll bring your screen down here briefly. Guys, if you have any questions in the chat as we're going along, feel free to post those. I'll make sure that we address any questions you guys bring up. Obviously, if you're seeing this for the first time you're hearing about ITS, you may want to watch that video first. But if the situation is that you're already familiar with that and you're ready to try this out, I encourage you to give it a shot for yourself, because this is very exciting solutions that we're showing here and can be tested with testnet tokens as we're doing today. All right, Idris, are you back with us? I see that you're unmuted, but I still can't hear you. Try. Oh, there you are. Perfect. You're back.
Yeah. Thank you.
It's worth the wait. I'll give you back the stage here.
All right. Thank you very much. So I'm still sharing my screen. So you guys, this is the first step that we just finished. Now we need to move to the second step, which is to deploy our token remotely, right? We've registered it as a canonical interchain token, and then now we can deploy it remotely. So I'll just go ahead and click on deploy, right? And then it's going to tell me, yes, you're about to start a remote token deployment. Starts. And then we click on start. Now I want to select a different chain because now I have created a canonical version on base. Now I want to choose optimism in this case, right? And then I can just proceed by clicking deploy, and I'll see the same pop-up. I'll connect, check like the wallets, and then check in wallets. I see like details of this transaction, and then I click, confirm. And now we have confirmed. So you can even click like this particular link directly to see the status of the transaction. But then I'll just be continue since I'm already tracking the link here for you to see. So once I click this link, I can see now, because this is remote deployment. It means that I'm doing something cross-chain. So now Axelar is tracking this. And then what are we calling? We are just calling this other method here, deploy remote canonical interchain token. And then we can see that already triggered here from base to optimism. And then if you scroll down, you see that it's on, the source address. They are both interchain token service. And then you can see other details like gas paid, gas spent, and all of that. If you want to also see like additional information, I think on CMO, you see like the payload and every other thing included. So now, well, this is remote deployment, and then we have to like wait for finality for about, I think in this case, it's 20 minutes plus. On minutes is usually faster, but then this is the finality that it takes for the deployment to happen and then completed on the source chain. So we have different times for different protocol. So now that we have this, we can go back to our frame, and you can see the next option is, yes, you have deployed remotely. We see the transaction here. What do we want to do next? We want to be able to transfer some of the token from base to optimism, like doing the bridging, the actual bridging itself. So I can click on bridge token, but before I need to transfer, I need the token ID. Like token ID is a unique ID that was generated immediately I register that token as a canonical interchain token, right? That token ID will be useful when I want to do interchain token transfer. Don't worry, I'm going to show you what the code snippet looks like, right? And then we click on retrieve. Now I have the token ID. Now the system is telling me how much you want to transfer. I can say 200. We have 10,000, so 200 is a fair, amount. And then I click submit. And then now I click on, I need to paste in like the receiver address, person that is supposed to receive this token on the Optimism network. So let me try to select a different account here. So I can have a different address. Yeah, so this 416, right? So now I can click on approve, and then I can approve. So what I'm basically doing is, because I want to give interchain token service permission to be able to mint token on my behalf. So I need to approve that interchain token service address to spend that amount of token that I want to transfer. So I can click confirm and then continue. So let's take a look at the transaction that we used to approve. You can see this is on base Sequoia 6 seconds ago. We scroll down, we see every details, and we see what the function was called. We have approved this spender to spend that particular amount. And then the next one is transfer. But before transfer, remember that we still have ongoing deployment happening here that we need to wait for. So while we are waiting for that, I'll just head over to Visual Studio Code and then go through it and come back to finalize this step. But before that, let me pause a bit. Do we have any question, Phil?
So I kind of followed up on one already, but I'll pull it up on the screen one more time. The question is, so you can simply switch tokens from chain to chain with Axelar. That's absolutely correct, and that's kind of what we're demonstrating right here. Once the token is enabled as an interchain asset using the ITS protocol, then you can simply move those tokens back and forth while maintaining the supply the entire time. Idris, if you want to add anything there, please feel free.
Yeah, that's correct. So, and then we have different options, just like Phil mentioned. We also have different options on how you want to move your token from one protocol to the other. So either you have a custom token, or you have a you want to create a brand new token, or you already have like your token deployed on one chain, like we did in this demo, where we deploy our token on base, and then we want to move like some amount, want to bridge it to Optimism. So that's another option where you can create a canonical version of that token that you have. So all of these things, you can do everything with Axelar, and with interchain token service, you can do it permissionlessly and then as fast as possible.
Great explanation. Perfect, perfect. And of course, I'd like to mention if you're working with multi chain tokens like this, let Moralis be your number one tool for developing your dApps across multiple chains. And I think you can see now why Moralis and Axelar make a perfect combination when you're planning your next project. And I'll leave it at that for now and let you continue here, Idris.
Yes, that's a very good one because Moralis simply offer like a lot of things for you to do as a developer. So, but one of the interesting things that you can check out is the APIs that are available to you. Like you can read on-chain data, you can do amazing stuff. Like at the end of this talk, I will tell you some of the frame hackathons that you can, apply to. You can build something and then participate in the hackathon and get some bounty. All of these things are pretty simple and very straightforward to ship. All you just need to do is to understand the concept behind frames, how to deploy your own frame, how to build your own frame, and then be able to participate in all of these hackathons. So let's go back to our Visual Studio Code. We'll see what the homepage looks like. To be honest, it gets like deeper the more you go to like different frames because you see what we were doing on each of these frames. So under the hood, I have the next page here, which is the home directory. This home directory is where we are, telling the user to enter the token address, just what you saw like a few minutes ago when I was going through the frame. And then we specify another button that says submit. So whenever a user submits it, the action here is post. We have different actions. So hovering on this right now, I think you guys can see it. So we have actions like post, we have action like post redirect, right? So in case you want to post or you want to post redirects, like after posting, you want to redirect to a page, you can do that. So all you just need to do is to specify what exactly you want this button to do for you, and then specify the target where you want it to go. In this case, I created a middleware that lets users select the chain, which is the next screen they are going to see. That's the next frame where they can select the chain they want to register that particular token on as a canonical interchain token, right? And then we have the image here. So by just calling this get frame response from our on-chain kits frame, we can return this, and this will automatically under the hood create the right metadata that we need. And then going to register chain, you can find that under the middleware, and then go to register select chain, right? And then under that place, you see what the next screen looks like, which is the button for Ethereum, Optimism, and Base, and then where it's supposed to go next after this screen. One thing you should note here that is different from what I've shown before now is you can see here, I'm setting a state. So this state, because I need what the user enter in the previous screen, which is the token address. I needed it here. So that's why I'm saving it. I'm getting it from the body that was returned here as this JSON, and then I'm setting it to a state variable called token address so that I can use it in the next screen. So if you have any idea of dynamically storing data and you don't know how to pass it across like different screens, this is how you can do it with states in frames, right? And then it goes to register verifier. This register verifier is supposed to verify what you want to register at the end of the day. Now, to register verifier, I'm also doing something similar, but in this case, I'm checking what was the button index that was clicked on. We have three buttons. We have Ethereum, we have Optimism, we have Base. So depending on the button that was clicked on, I'm setting a particular chain name. This is a unique chain name that we registered on the Axelar network. So I'm making sure that I can pass in the chain name depending on the button index that was clicked on. So if it is index 1, that means it's the first button. Then the system knows that it is Ethereum Sepolia. If it is 2, it is Optimism Sepolia. If it is 3, then it is Base Sepolia, right? And then we are decoding the states. Remember that I saved a state. I saved something in the state in the previous screen. I'm decoding that state, making sure that I can get access to what the content is, passing the content there, like doing a JSON parse to get the content, and then finally get my token address here. But then I don't need the token address here. I still need it somewhere else. I need it in another target because now, see what we are doing here in this button. The action here is transaction. We are not just doing a post that redirects to a frame. We are sending a request on chain, right? And I'm telling it, hey, send this request directly to this particular action. And then once it is completed, redirect back to this action, right? One thing about frames and also using this particular package is that you can set the target, and then if the target is like a transaction where you want the user to sign something with their wallet, after they sign it, you can also tell frame that yes, after the signing is completed, redirect to this frame and then continue the process. So this is what I'm doing here. Whenever a user click on register, it's going to initiate registration on chain under the hood. And then once it is done and the user sign and everything is completed, it will direct back to this screen, right? And then in this screen, we have the success that is just going to show us a link to the transaction link and then the next step that you want to do, right? You can see it's pretty similar, but then I'm also repassing the states. One thing you should know that is very important is that if you want to keep track of the states across like frames, maybe just like what I'm doing here, when I got the token address, that was like 2-3 frames ago away, right? And then I don't need it in the next one. I need it in like 3 steps. That's 3 frames after, right? So you can, what you just need to do is to just pass the state across different screen by decoding what it is from the previous one and then sending it again. So in the previous one, I already encoded, like I saved it to the state and then I decode it here and then pass it again and set the chain name depending on what the user selected in the previous step. So now let's go to register token. This is where the action happens. So if you go to actions here and then open register token here, you have the functional. This is where we are actually doing the registration. We have like a few things imported here, and also from VM, we also have the frame transaction response, and then we have the interchain token factory. This is the contract where we are calling the function to register that token as interchain token, as a canonical interchain token. And then we are decoding the state again here, but now we are getting the token address and the chain name, so we know the chain. And I'm also doing a validation here, just to be sure that this is a valid, token address. And also now this is where I want to send the transaction. I need to encode it here. I'm specifying the ABI. I'm specifying the function name, which is called register canonical interchain token. And then I'm specifying the token address. So if you could remember to go to our presentation here, this first step, this is the function that we want to call. So going back here to our code, and then I'm doing like a chain map just to ensure to know the ID that I'm supposed to return, because I need this ID so that the system know the contract or the chain they're interacting with. So I'm using that here. I'm setting each of the IDs to this parameter. And then what I'm doing is to map the chain name that was received in the previous screen so that I can get the ID. And then I can pass in that ID to this function here, pass it, call this method, specify the data, specify where this is supposed to interact to. And because I'm not paying.
Okay, I think you noticed on your end, you did cut out just then.
So I'm not paying for a special gas. I'm just passing 00 here because this particular transaction does not require gas payment. But I'll tell you, does not require like adding extra value as gas payment for this call. But in the next one that we'll be doing, we'll see how we specify gas payment. And then finally, we are returning this JSON of the transaction data. And then once this transaction is successful and everything goes fine, remember that there's a fallback screen, and the fallback screen is called register token success. And then under the register token success, we have this screen here. So this is the screen that it's supposed to land on immediately after the transaction is completed. User has signed the transaction completed, and everything went well. So what I'm doing here is to decode again so that I can get the token address, because I still need the token address. Remember what I mentioned, that if you want to like reuse things, even though you are not using it immediately in the next frame, you can pass it across as a state variable on each frame. And then I want to use it here. I'm not even using it here. I'm still passing it again as a state because I will use it at the end of the day. So I'm passing it as a state here. But one thing you should see that is different is, see the action of this button is showing link, right? And then under the link, I've configured in such a way that the body that was returned here, I can get the transaction ID of that particular transaction and then click on it to view the transaction. And also another button that leads to the remote deployment, right? To the action for remote deployment, right? This is similar to what we have seen before. But then the next step for us is to go to the remote deployment, to start the remote deployment. And you can see this API action leads to start deployment. So if you go under action, you see something like start deployment. And then this start deployment, what I'm just doing here is this, like pretty simple, similar to what we've done before. But then I am clicking on deploy select chain, because now that they want to start the remote deployment, I need to know which chain they want to deploy on. So now we go back to our previous screen that we've seen before, which is deploy select chain, where the user can select chains that they want to deploy on. So this can be found like any intermediary screen like select chain, verifier. You can find all of them under the middleware. Because they are not really screens, like actionable screen, they're just like intermediary to get users feedback before we proceed to the action, to the transaction frames, right? So if I click on deploy select frame here, you can see that I have this information, which is similar to what we've seen before. We've seen like this code like a few times. You can decide to like create a particular function, a utility function, and then just call them instead of repeating, the code every time. But then I just wanted to showcase that, yeah, you can pass in all the tokens, like you can pass in the state variable, decode it, and pass it across different screens. Yeah, so I'm passing it here again. The reason why I'm passing it across every screen is because the frame does not keep like the memory of what you've done like 2-3 frames away, right? It only keeps what you've done in the previous frame. So even if your previous frame, you're getting the data and then you move on to another frame, you need to keep track of that data so that when you move across different frame, you can get hold of that data across all the frame till when you probably need that particular data. So in this case, user selects the chain they want to deploy on, and then we redirect them to where? Deploy verifier, which is the post URL. Go back to deploy verifier. We open that up, and then what we are seeing here is to decode and do something similar we did before to know which button index was clicked on, and then decode the token address again. And now this time I want to send the transaction. I'm not just redirecting. I'm sending the transaction to where? Deploy token. And then once the target is completed, user has signed the transaction, it will fall back to deploy token success. Let's look at what deploy token is here. So we have deploy token similar to register token, action. But what we are doing differently here is that we are decoding some information, the chain, the token address, and then we are calling a different function here, which is called deploy remote canonical interchain token, right? And I'm specifying base sepulchre. So one thing you can do here is that you can dynamically create you can dynamically get what to be specified here from the user. But in this case, because of demo, I'm just saying yes, it is base, right? But still, you can get the data from the frame, from users' input on the frame, and then passing whatsoever value they selected here. And then this particular function takes in few parameters. The argument here is we have string, we have OX, we have string, and big int. Let me quickly show you what that looks like on chain. 1 second. So docs, you can go to docs so that you know the parameters that you want to pass. It's very important to know which parameter you are passing. So this is the contract here. And then we are doing remote deployment. Let me do it. Sorry, I'm going to Interchain Token Factory, and then I can find remote deploy remote interchain token. Oh, yeah, deploy remote canonical interchain token on the contract. Let me zoom in so you can see the screen properly. And then you can see that we are passing the original chain, the original token address, the destination chain, the gas value, right? Which is the same parameter that I'm specifying here. The original chain here is base. The address, the original chain address is token, this is our token address, the chain name, and then the gas value here. So this is what we are passing here. And then we are sending the transaction I'm passing other value because we need value here. We need like to specify the value. That's why you are seeing we are specifying value here. We are not just passing OXO. And then once that is done, once this is completed successfully, there's a fallback screen that goes to deploy token success, which shows this the next frame that you might want to see. And we are decoding the state again. We get the transaction ID where users can verify this transaction on chain, and then bridge token, which is the next step. But because we need token ID to be able to do transfer, like bridging token here, we need to request the token ID. So what I'm doing from request token ID, if you go to actions and then go under request token ID, what I'm doing here basically is to go on chain and then read the token ID based off the token address. So you can create a chain and then call this function that says canonical interchain token ID and specify the token address. The system is going to return a token ID for you. And now that you have a token ID, you can proceed to ask for the user the amount that they want to transfer, which leads us to the next screen, start transfer. And start transfer under start available amount, this screen just allows the user, it allows the user to enter the amount they want to transfer, the after transferring where the system should redirect them to, and then we are setting the state variables here. Now we have the token address, the token ID. So if we go to receiver, which is where the user is supposed to enter their receiver address, we are decoding as usual, and we are telling the user to pass in the address that wants to receive this token. And then we are going to the next action, which is what approve token. Because we want to approve ITS to be able to spend this amount of token, the amount of token that I want to send. So now we are setting, you can see I'm setting the state variable again here. We have the token address, token ID, and now we can get the input text from the previous screen to know the amount that was entered. And then we go to the approved token, like approved token here. And then inside the approved token, we have where we are decoding similar to what we've done before, logging all of these things to be sure that we have all the right data. And then we can call the ERC-20 token approve on our own contract, right? I'm calling the approver here and specifying the interchain token service address and the amount that I want the system to approve, and sending the transaction. I'm not passing any value, which is similar to what we've seen before. Like just having this frame transaction response, you can just call this, create this object, and then pass it in, and it's under the hood going to, make this transaction happen. So after approving, we need a fallback screen. That fallback screen is the success screen here. When the transaction is gone successfully, and now we want to redirect to a page where user can click to view transactions or transfer their token. So now we have like information that we have decoded from the states, and then we are saving it to the state again so that we can use it in the next screen where we actually do the transfer. You can see this transfer now. We have this final step, which is the transfer token here. And if you go through the transfer token routes, you can see this route where we are, doing pretty much the same thing, getting all the parameters ready, decoding the states, getting the amount, the token address, the receiver address, and the token ID. I'm passing an empty metadata. That's why I'm configuring this, right? And then see what I'm calling differently here. This is a different function that I'm calling interchain transfer, because I want to do the transfer now from base to Sepolia. And then I need to specify my token ID and optimism Sepolia, the destination chain. In this case, is optimism Sepolia. And then the receiver address, the int, that's the amount, empty metadata, and then the value, the gas value that you're paying, right? And then we'll send the transaction as usual to the base network, because this is happening from base to optimism, right? And then once the transaction is successful, we redirect to the fallback screen, which is transaction successful frame, where we can click to view the transaction. So that's what the frames looks like. Feel free to go through it on your own. It's very simple. It's like, it looks repetitive at some point, but the whole idea is that you get the concepts and the logic behind this thing. So let me quickly go back to our frame here. Let me confirm if this is done. This is not done here. It's just like 3 minutes left. Maybe we should wait. Or what do you think? Just 3 minutes. We don't have time. Phil, Can you advise here?
Well, yeah, let's see
Yeah.
if it comes through here in the next couple of minutes because we do have a quick question I think we can follow up with in the chat. Now, this is
Okay.
regarding chain support. Now, if you're
Okay.
interested in a longer discussion on chain support, check out our roadmap roundtable with Galen from Axelar over on our Morales Money YouTube account. There, you're going to
Yeah.
get a 30-minute discussion specifically about what's coming and what chains or what chain support is planned. Now, I can comment on behalf of Morales. We have API support for Solana already today, and Solana support is available in our Token Explorer for Morales Money Pro members only. So if you are a Morales Money Pro member, then check out that Solana support over there. Algorand may be on our short list. I'm not sure on that one. I have to check into it. But I know that we're working to, on the Morales side, support the most popular chains first so that we're able to assist the greatest number of developers with each rollout phase. Did you want to comment at all, Idris, on support for Solana? I know you guys mentioned it's coming. Maybe you
Yeah,
have more
it's
details than I.
coming. It's coming. Yeah, it's coming. It's definitely coming. It's almost here. So we have the interchain amplifier that we're currently working on, which is a programmable layer on top of the Axelar network that will allow anybody in the world to permissionlessly connect their chain. So one of the first integrations I will be doing that will be going live soon as possible. We'll communicate all timelines. Is Solana. We have Solana coming. We have Sui coming. We have and I think Flow blockchain, yeah, coming soon. So all of these things will be connected permissionlessly on top of the Axelar network with the interchain amplifier. So you guys should just wait from the Axelar side of things. It's almost here. We have cooked a lot. We're going through like iteration of builds, getting feedback, and then it's currently on DevNet. It is going live on testnet and then mainnet very, very soon. So you guys should just keep it locked, follow us, and also join our streams where we also get to give you like information on the progress we've made so far, some of the things we've done in the past, and where we are heading to at this point. So yeah, Solana is coming very, very soon.
Perfect, perfect. I see we've got less than a minute left for this to complete here, so let's go ahead and stay on the stream here just long enough to see that
Yeah.
on-chain validation. Now that said, if there are any other questions, now is a perfect time, guys. We're going to be sticking around here for another 30 seconds or a couple of minutes, depending on how long this takes. So if you do have anything else to ask or comments on what you've seen so far, please post them in the chat and we'll make sure to pop them up on screen for the benefit of everybody. If you're watching over on X and you want to post a comment there, we also see those, just an FYI. And while we're waiting, oh, I see it's already confirmed here.
Yeah, so it's approving right now. So you can see all of this information in case you want to check out, maybe you're trying it yourself. There are so many other information that you can keep track on the scan. So this is just to ensure that we have like end-to-end system working and everything is finalized on chain before we proceed to do transfer, because this is where the deployment happens from the base Sepolia to optimism Sepolia. So we are canonically registering or deploying our token remotely from base to optimism Sepolia. So once we have that approved and executed,
there we go. All right, folks, and we're about to just recap really quick here everything that we've gone over. While we are waiting, I want to thank Idris for joining us today of Axelar. Very excited to be working with you guys as you really help to bring to life that multi-chain future that we also believe in and support. And so just always enjoyable and informational when we get a chance to have you here on stage. So thank you so much for that. Let's go ahead and wrap it up because we are a little bit over an hour already. But any additional details you want to give before we close out, we're happy to hear them.
Yeah, so now we have this successfully done, and then we can just do the last step and then we go back to the slide. So now this last step is to transfer, and then we can just confirm that transfer. Here, remember the amount we wanted to transfer here? That's 200, right? So
that's
now
correct.
we've transferred successfully, and then click, and then you can click transaction to see if the transfer has been completed. So once it has been completed, you're going to see it in your wallet. But then let me show you one thing, just for you to know the system is currently tracking it. You can see like the token we just created was where is it? Where is it? Where is it? Yeah, this was the token. This is the token we just created right now. Is this? Oh no. Okay. Okay, yeah, I think it's this. Yeah, so the transfer is
Farcaster ITS.
exactly. So this is still 10,000. The transfer is currently ongoing, and you should see that the balance will be tracked across different chains. I don't know if it's this or this. Now I'm confused. I don't know why it was registered because I can see this was sent, just some minute ago. I think it's this one. So now we have 200 sent already. Yeah. So I'm not sure why the wallet is showing it twice, but now you can see that we have 9,800, and the expectation is that the receiver address here should receive that token at the end of the day. So
I think I saw what happened there, Idris. We accidentally minted the token twice in our demonstration earlier.
Oh, I
but
see.
that's no problem, guys. This is part of the reason why we use testnet. Minting it twice didn't cause any issues there. It just means that we had duplicate names for our
yeah, exactly. Yeah, exactly. So now we have that, and then you can transfer, and that's transfer initiated, and that's end to end. But one thing for you to see, this is a frame validator. Your users cannot interact here. Let me do one last step. Let me go back to the home page. This is Webcast client. This is the home page, right? Now we are done with the frame. Everything is working. We are excited. We want to tell the world about it. Just come here, click on cast, and then just drop it here. And then it's going to load it up by default. And you can select the community that you want to post it in. So I'm going to post this into, I don't know, maybe cross chain. Yeah. So, and then casts. So once I cast this, cast successful, right? You can see it here. So anybody can just click on this to get started, and then they see this. They can go through all of this flow within the Webcast client without having to leave the application, right? So that's the main idea. Something you can interact with, something that gives you that flexibility to interact with it, right? So back to our presentation so that we can round up. We're already out of time. I wasn't expecting to get this really long, but then the point is that you guys get what we are currently doing, and then things that you can build with frames. So if you haven't scanned this QR code, this is opportunity to scan. It takes you to complete, the project on GitHub, where you can, see the end-to-end code base. And then finally, we have frame hackathons going on, the Arbitrum and Farcaster Buildathon. Just Google it, Arbitrum and Farcaster Buildathon. On-chain summer is still up. We have bounties. I think they have about 20 ETH bounties for frames, people that are building frames. And also, if you want to see like all the frames bounties that are available, even the ones that I didn't mention here, the ones that are just going to be rolled out today or tomorrow, you can go to mountcancer.xyz/tag, and then you see all the frames that are currently up and running that you can participate in the hackathon. So yeah, I know you might have like different questions or like things to share, feedback, comments. Please, we have the Axelar support. Just go to our repository, create. If you have any issues, we get notification almost immediately. If you have any issues, we'll be happy to help you. We'll be happy to answer your question. And also, if you are trying Axelar for the first time, go to Axelar examples, which is github.com/axelarnetwork/axelar-examples. You see a lot of examples to play around with as a developer. Maybe for sending custom messages, for sending asset, deposit address, interchain token service, all of these things. We've created this is a robust repository that we have that has a lot of examples that you can play around with, and you can do all of these things locally or on testnet. So this brings me to the end of this presentation. Thank you once again, Morales, for having me. Thank you, Phil, for hosting this as usual. So guys, you can scan this QR code and give me feedback on what you think about this workshop. How has this workshop been able to help you? The survey takes less than 1 minute to fill in, and then we'd love to hear from you. I would love to get feedback personally so that I can improve on my next presentation as we move on. Thank you very much for joining my session.
It's our pleasure to have you, Idris. Thank you so much for joining us again. And also wanted to say, if you're developing cross-chain or for any chain, make sure to check out docs.moralis.io so that you can take your dApp to production faster than any other solution on the market today. All right. Well,
Yeah.
we'll see all of you in the next video, and have a wonderful day.
Yes. Bye, guys.